Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for data management students who are reviewing for their test next week. The test is on Chapter 5, and the questions we're looking at in this video can be found on pages 324 and 325 of your textbook. And by the way, this is video number 4, so hopefully you've checked out the other 3 videos first. So let's go ahead. We're now taking up question number 12. It says in a manufacturing process, 0.2% of brake pads that come off the production line are considered defective. Determine the probability that at least one brake pad is defective in an order of 200. So if at least one of them is supposed to be defective, the opposite of that is that 0 are defective. And that's the way we're going to do this math. Please don't try to do normal approximation, because approximation is an imperfect method. But in this case, it's very easy to do the complement. So the opposite of at least 1 is 0, and then subtract, and that would give us the exact answer. So that's the method we're going to use. We're going to find the probability of 0 defective, and then we'll subtract. So out of 200, I want 0 to be defective. So 0.002 is the probability in decimal form. And I want 0 of those, and therefore I want all 200 to be from the 0.998 working probabilities. So, and that's to the exponent 200. So if you type this into your calculator, you get 0.6701. And therefore the probability that I have at least one being defective is 1 minus that. And 1 minus 0.6701 is 0.3299, or about 33%. Part B says, what is the expected number of defective pads? So because this is a binomial experiment, you either get a defective pad or you don't. We can use a binomial experiment shortcut where we multiply n times p, and in your calculator you would get 0.04. Oops, no you wouldn't, sorry. Just a second. I'm not reading my calculator very well. You should get 0.4. So not even 1 is expected to be defective in a group of 200. And that makes sense because we know that more than half the time we don't have a defective brake pad. So make sure that your answers sort of align with each other. Okay, next question. In a bag there are 10 white marbles and 6 red ones. 4 are selected at random. Determine the probability that there are exactly 3 white marbles, and can this be represented by a binomial distribution? Well, I certainly wish that they'd asked A first because I want to talk about A first. Can this be a binomial distribution? No. When you reach in and pull out a marble, the next marble you reach in will have a different probability. So for example, the first marble being white is 10 out of 16. But you don't put that marble back because you're selecting 4 marbles. So the next marble being white would be 9 out of 15, and so on. So because the probability of drawing a white marble, for example, changes as you go through the experiment, this is not a binomial experiment. So we certainly can't use the binomial experiment shortcut. We're going to have to use straightforward probability. So determine the probability that there are exactly 3 white marbles. So if I have 16 objects, and I'm drawing 4 of them, that's what my sample space looks like. Because there's no reason to suggest that there is a reason why the first marble has to be red and the second has to be white. In other words, order does not matter. Now, I want exactly 3 white. So out of 10 white, I want 3. And therefore, out of 6 red, I want 1. And this will just be my calculation in my calculator. Let's see what happens. So 10 choose 3. Is 120. So I'm going to do in the numerator 120 times 6. 16 choose 4 is 1,820. And then calculating that out, we get 720 over 1820 And let's make sure we're good at math here. 720. So 720 over 1820 reduces to 36 over 91, which is approximately 40%. So there's a 40% probability of drawing the white marble. So we've already talked about B, and it's because trials are not independent, or if you want, the probability of success changes with each trial. C, if the discrete random variable x is defined as the number of white marbles in a sample of 4, determine the probability distribution. Okay, so I'm going to do that on a nice clean page. Oops. So actually, I'll write here. So x is the number of white marbles, and I could get 0, 1, 2, 3, or 4. And we've already done the probability of getting 3 white marbles and found that that was, and this time I want 4 decimal places, 0.3956. So 0.3956. So we need to fill in the rest of this table. So let's go do some math. So if I want 0 marbles to be white, then all of them have to be red. So that would give me an event space of 15. And my sample space in every question is going to be the same. And it's going to be 1820. So 15 over 1820. And I'm not even going to worry about reducing. This time I just want the decimal value. Is 0.008242. So 0.008242. And then keep going. If I want 1 white marble, then I need 3 red. And again, it's out of 1820. So 6 choose 3 times 10 choose 1 gives me 200. So 200 out of 1820 gives me 0.1099. So I can fill that in, 0.1099. And again, continue filling them out. And I'm going to press pause because I don't think you need to necessarily see it. Okay, so I finished doing the probability distribution table. I found that, again, we had done these together. And then here, if I want 2 white, then I need 2 red, and that's 675 for the numerator, divide by 1820 for the probability. Then we'd already done 3, so here's 4 white, so 10 choose 4 and 6 choose nothing. That gives me 210 divided by 1820. So here's my probabilities, and I've already added them up to make sure that they equal 1, or approximately 1. Good. So D, design a simulation that will verify the probability distribution you determined. So obviously that's not part of the test because you're not going to be designing simulations for me on this test. But we can fast forward to E, which says determine the expected number of white marbles. And so that's where I'm going to multiply together 0 times the probability, 1 times the probability, and etc., and calculate the expected value. So if you do that math, what should you get? Doing that math, you should get an expected value of 2.5. So I expect that on average, I saw 2.5 white marbles. And that makes sense. Again, I'm drawing 4 marbles, and more of my sample, more of my original space are white. And therefore, I expect that on average, I see slightly more white marbles than I see red ones. Okay, what's left? You roll a die 10 times, and 6 times it comes up showing 5. What is the probability of this occurring? So this is a binomial because it either rolled 5 or it didn't. So the probability that I have exactly 6 successes, so 10 choose 6, there's only a 1 in 6 probability of getting that 5. And I want that to happen 6 times. So this is probably not going to be a pretty big probability. Let's see what it is. So 10 choose 6 times 1 over 6 exponent 6 times. I know your favorite part of this video is hearing me type stuff into my calculator. That's like awesome sauce right there. It's going to be the next internet meme. I get, here we go, 0.002170, or less than 1%. Conduct a simulation to show this is an unfair die. Well, I mean, we're not going to do that. However, I did it just because, you know, I'm cool like that. What I did was I tossed a coin 10 times, recorded how many times that I got a result of 6 or more 5s. Wait, let me start again. I tossed a dice 5. I'm not pressing pause, sorry. You have to accept these mistakes. I rolled a dice 10 times. So I used the computer to do it, and I did roll a dice 5 times. And let's look at this. So each time, when I rolled the dice 10 times, I asked the computer to count how many times 5 came up. And that's what this table here is doing. It's showing me that the first time I rolled 10 times, I got 0 5s. Then I got 2 5s. Then I got 3 5s. Then I got 1 5, and so on. So each of these, 1, 2, 3, 4, 5, is an experiment where I toss the coin, the dice, 10 times. Then, for recording purposes, I said record a 0 if it didn't happen. So if I did not get at least 6 or 6, then put a 0. And if I do get 6 5s, then put a 1. And you'll see, look at all the zeros. And then I graphed it, and you can see that after 1,000 experiments, so that's a total of 10,000 rolls of the dice, one time, beep, it came up with 6 5s. So that's definitely something you should not expect to happen. It doesn't mean it's impossible. It just means I don't think that's really a fair dice. And I think that's everything. Boy, oh boy. Okay, so that's all the questions that I had assigned you for review. Certainly post questions, comments, more questions you want me to take up in the comment section, or you can email this address, however you do that through YouTube. I hope that was helpful, and we'll see you later. Happy studying.